So we're still solving equations, systems of equations, and we're still going to use elimination. So we're going to use elimination with one more different operation, right? The last video we looked at was addition and subtraction. And so this is elimination using multiplication, right? But the idea still is that we are eliminating something. We're trying to get rid of a variable so that we can solve and know what the other variable is, right? So still looking at a three-step process. And so here we go. I'll look at an example and kind of talk you through these steps, and then we'll see what happens. So step one is, and look, we're not going to get away from the fact that our x's, our y's, our equal sign, and our constants, that everything is lined up like that. That's just that's like breathing. Like that's going to have to happen. Maybe even your first step is to make sure that that has happened. Okay, so step one, using a multiplication, is we're going to multiply at least one equation. Okay, so that makes it sound like we might have to multiply both equations by a constant, but we're going to multiply at least one equation by a constant to get two equations that contain opposite terms. Okay, so remember, we're trying to cancel out an x or a y, and to do that we need it to have the same coefficient but with opposite signs, so one positive, one negative, so that when we add them together, right, that variable disappears. And then we'll add the equations, eliminate the variable, and we'll solve what's left. And then step three is, let's go find that other variable, right? So if you'll notice here, 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. There are no coefficients that match, okay? 5 and 2 don't cancel, 6 and 3 don't cancel, but if I'm going to use elimination, something has to go away, and that's where step one comes in. Multiply by a constant to get two equations that contain opposite terms. So let's look here at y in these two equations, and if I take that second equation and if I multiply times a negative 2, watch what happens. Okay, I'm just going to multiply the whole equation by negative 2, right? So negative 4x minus 6y equals 10, and I'm going to rewrite that top equation as is, not going to change a thing. Now what do you notice about those y values? Right, plus 6 minus 6, which means I can add those two equations together and the y's disappear. Okay, so you're going to have to be able to see what equation needs to be multiplied by what value to get that coefficient to match up. Which one is going to be easier? And we'll talk about things like that. But here we go. I multiplied the bottom equation by negative 2, and that made my y values same coefficient but with opposite terms. So now I can add these two equations together. 5x plus a negative 4x leaves me with an x. Plus 6 minus 6 disappears. Minus 8 plus 10 leaves me with a positive 2. And so without doing anything else, I actually already know that x equals 2. Okay, that's part of my solution. Now, we've done the next part a good bit already, taking x and plugging it back in to figure out what the other value is. So I'll do that very quickly. 2 times 2 plus 3y equals negative 5. So y would equal negative 3. So that my ordered pair would be 2, negative 3. And again, we could take that 2, negative 3 and plug it back in. So again, look at this. Feel confident right here. Rewatch this part of the video again. But I'm trying to get either the x's or the y's to have opposite terms. Same number, different sign, so that I can add those two equations together. And this one is yours. All right. So 6x minus 2y equals 10. 3x minus 7y equals negative 19. I don't have coefficients that are opposite, and so I have to decide what I'm going to multiply which equation by to get something to match up. So this is one of those things you kind of have to, eventually you have to kind of feel and just kind of see what happens here. But to get that 3x to match that 6x, I can multiply the bottom times -2. Negative 6x plus 14y equals a positive 38. And all I did was distribute a -2 to that entire bottom equation. That's one of those things that we get to do. Not changing the top equation at all. Just going to rewrite it. And now you can see plus 6x minus 6x. That eliminates by adding the two equations together, which leaves me with 12y equals 48 and y equals 4. And then that y equals 4, we get to plug it back in to find out what x equals. Right? So 6x minus 2 times 4 equals 10, which means that 6x equals 18, x equals 3, and that's my ordered pair, 3, 4. All right. Now, if we jump back here just a second, you'll remember that it says multiply at least one equation by a constant. And I told you, sometimes you'll have to do two equations by something, as in this case. Okay. 3 can't multiply something. 3 can't be multiplied by something to get to 4. 4 to 3. 3 to, right? Nothing works out well. And so we have to decide what we're going to multiply both equations by so that we can get coefficients to match. Okay, and again, this is something that we'll play with and you'll get better at it. I'm going to multiply the top equation, and so here we go. I'm going to pick the y's to get rid of. Okay, between 2 and 3, my least common multiple would be a 6, and so multiplying the top equation by 3 would give me 12x plus 6y equals 24. And remember, I'm going for opposites, so I'm going to multiply the bottom by -2. Here's y, negative 6x minus 6y. See there, positive negative 6. That's what I want, so that I can, in this next step, add those two equations together. And x equals 1. So now we can plug that back in to either one of these two equations to figure out that y equals 2, and that's my ordered pair. Okay. Now, this one is yours. See what you can do with it. All right. So x is lined up, y is lined up, equal, constant, all that looks good. Neither one of these variables looks any easier than the other one to get rid of. I do notice that my y's are already opposite signs. So if I multiply the top one times 5 and the bottom one times 3, the y's are going to match up. They're going to have opposite signs for the same number. 25x minus 15y equals 30, and 6x plus 15y equals -30. Okay, and we're going to add these two equations together. So 31x equals 0. X equals 0. Okay, now x equals 0 makes this really easy to solve, because that means that 5y equals -10 or y equals -2. Right, so x is 0, y is -2. That may have felt funny when you were working that yourself. X equals 0 is a fine answer. It's not undefined. It's not infinite solutions. It's just x equals 0.